Making potato chips is a carefully controlled process. Actually, it's several processes, all involving human labor and complex machinery. So how does Frito-Lay know when and where they have a problem? In the past, a company would inspect the product at the end of the process. But that's a little late to know if something's wrong. There are better ways. Sampling, as we saw in an earlier program, is one way to check on the process as it's happening. But as it turns out, it's only the beginning. Frito-Lay is one of the many American companies to add a new tool to their production line, Statistical Process Control, or SPC for short. It's a way for people directly involved in a process to know when to make changes and when not to. SPC is becoming universally accepted in American business, but it took a while to catch on.
I was a little fearful of the whole thing, not being totally familiar with statistics. It was something new to me, so there was a certain amount of reluctance on my part. But I soon became a believer once we started the process. Our variability from bag to bag diminished. We've probably made a 50% improvement in variability since we've instituted SPC in our operation.
Statistical process control is made at critical control points in the process where you can actually impact the quality of the product. And by setting up statistical control charts or Shewhart charts, you can obtain signals that tell you when the process needs attention and when the process is best left alone.
Let's look at the production of Ruffles to see how statistical process control works. Every 15 minutes, Karen Engels collects 3 batches of finished Ruffles for salt analysis. Salt content is a delicate balance for Frito-Lay. It has to be great enough to achieve the desired flavor, but small enough to satisfy consumer health concerns. To check on the salting process, each batch of chips is ground up, weighed, dissolved in distilled water, and filtered into a beaker. The electronic salt analyzer gives a precise readout of the percentage of salt. This sample's salt content is 1.9%, just slightly greater than the target amount of 1.6. Karen repeats the process with the other 2 batches. The information is then collected by Barbara Boudreau for further analysis. Barbara averages the salt content of the 3 batches and comes up with the sample mean. She plots the mean on this control chart, a special kind of graph which lets her know when the salting process is out of control.